In this lesson, we're going to learn how to solve absolute value inequalities. Simply put, an absolute value inequality is an inequality that contains an absolute value symbol. It's just like an absolute value equation, except it has a greater than or equal to, or perhaps a less than. In our first example, we have the absolute value of 2x plus 3 is less than 7. The reason I say these are a lot like absolute value equations is this. Our first step is to change it into an equation. So notice what we've done. We changed the less than sign into the equal sign. Now we're simply going to solve the equation like we've done before. We write our two derived equations, 2x plus 3 equals 7, and 2x plus 3 equals negative 7. That gives me solutions of x equals 2 and x equals negative 5. Now, we can't forget that we had an inequality. And so we have to do a little bit more work than we did for the plain old equations. The next thing we'll do is take those solutions we got and plot them on the number line. I'll put an open circle at negative 5 and an open circle at 2. Why did I put an open circle, you ask? Well, notice the original inequality was simply less than, not less than or equal to. So that means we have an open circle. Finally, we have to determine where to shade. We have 3 spots on the number line where we could shade. To the left of negative 5, between negative 5 and 2, and then to the right of 2. So we have to figure out where we want to shade. This is how we do it. We pick a spot in each of the sections. So in the first section, we're going to pick a spot. Let's say, I don't know, how about negative 10? We plug it into the original inequality. 2 times negative 10 is negative 20 plus 3. That is negative 17, which the absolute value of is 17. Now, is 17 less than 7? No, it's not. So we do not shade in that area. Next, we'll pick a spot between the negative 5 and the 2, and we'll plug it into that same inequality. How about 0? 2 times 0 is 0, plus 3. 0 plus 3 is 3, and the absolute value of 3 is 3. Now, is 3 less than 7? Yes, it is. So, in that area, we are going to shade, and I put a check mark above it so that I remember I want to shade there. Finally, we'll pick a point in the last section, and we'll plug it into the same inequality. How about we choose 10? 2 times 10 is 20, plus 3. That's the absolute value of 23. Is 23 less than 7? No, it's not. Since it's not, we do not shade in this area. So the spot where we shade is exactly where the check mark is. Now, before we go and do the shading, please make note that while in the last section we picked 10, we could have picked 9 or 8 or even 5, anything that was in that area. Now, let's do our shading. We want to shade where the check mark is. There we go. And we've shaded the solution set to the inequality. Now, of course, we can write this as an inequality. We could write this using set builder notation, or we could write it using interval notation. Any of them would work. They're all equivalent. The second example is for you to try. This is exactly the same, except this time we have a greater than or equal to. Remember, the first thing to do is to change the inequality to an equation. Then write your 2 derived equations and solve them. Those become your points on the number line. Once you've done that, do your test points to determine which parts of the number line you'll shade. Please pause the video here and come on back. We'll check your work. First thing I did was change the greater than or equal to an equal sign so that I had an equation. Then I wrote my 2 derived equations and I came up with the points a equals 4 and a equals negative 1. Notice this time on the number line I put closed circles because the original equation was greater than or equal to. Now I have to determine where to shade. I pick some test points and I find out that the two ends are where I'm going to shade this time. And so I do my shading there. Now I can write my set using an inequality, set builder notation, or interval notation. Once again, all four of these different notations, the graph, the inequality, the set builder, and the interval, are equivalent. Example 3 is also for you to try. Remember, change it to an equation and then solve for m. Once you've done that, you can then graph your points, do the shading, and then write the set using the various notations. Please pause the video here, then come on back and we'll see how you did. Let's take a look. First thing I did was change it to an equation, and I wrote my two derived equations. I subtracted 2 from each side, and that left me with m over 3 equals 0, m over 3 equals -4. M is divided by 3, and the opposite of dividing is multiplication. Multiply both sides by 3, I get m equals 0, and m equals -12. Those are the points that I plot on the number line. Again, because it was less than or equal to, they're closed circles on the number line. And now I determine where I'm going to shade by picking test points, and I shade in between those 2 points in this case. Finally, I have my 3 different notations that I can use to write my set. Example 4 is also for you to try. Please pause the video here, then come on back. We'll see how you do. Let's see how you did. We have the absolute value of 2x minus 3 all over 8 is less than 5. First thing we did was change that to an equation, and now we still have the absolute value of 2x minus 3 all over 8. We need the absolute value to be alone, so we multiply both sides by 8, giving us the absolute value of 2x minus 3 equals 40. Now that our absolute value is alone, we can write our two derived equations. 2x minus 3 equals 40, 2x minus 3 equals -40. That gives me x is 21.5 and x is -18.5. I plot my 2 points on the number line, and I do my test points to find out where I shade. I shade in the middle. Now that gives me the inequality in set builder notation and an interval notation, the solution set to this absolute value inequality. On example 5, again, we have to get the absolute value alone. Please pause the video here, give this a try, and then come on back. We'll check your work. Let's see how you did. We began here by rewriting our inequality as an equation, subtracting 3 from both sides, and that gave us our absolute value of x minus 6 by itself. Now we write our two equations, and we solve those, getting 8 and 4. We plot the numbers 8 and 4 on the number line, and they're closed circles because our original inequality was greater than or equal to. Now we do our test points to find out where we shade, and then we can write our inequalities. In our final example today, we have a couple of things going on. We have +2, and we'd also have multiplying that whole absolute value by the value 3. Once again, I begin by getting it so that it's an equation, and I can subtract 2 from both sides. That gives me 3, absolute value of x minus 3 equals 5. Divide both sides by 3, and the absolute value of x minus 3 equals 5/3. Now I can write my two equations, and I can solve. X equals 14/3, and x equals 4/3. I plot the 2 points on the number line, and now I do my test points, and I shade. Now I can write my set using inequalities, set builders, and interval notation. Really, when you're solving an absolute value inequality, here's what you need to remember. Simply rewrite it as an equation and solve it. Once you get your two possible solutions, plot those points on the number line. Once you plot them on the number line, choose spots to test it and find out where you're going to shade. Finally, you can write your set using any of our notations as an inequality, in step builder notation, or using interval notation.